All right, so what I'm going to do is I'm actually going to take a lot of the pieces of the previous example and kind of just bring them on with us over into the next slide, because I think that there's something else interesting to learn about this particular circuit that we should look at, and that is going to be, let me go ahead and just put, so we already know what the current looks like as a function of time, but what I want to examine now is, let me just take these axes and copy them. We'll make another plot here. And so this one was IL of t, which we know is this current here flowing through the inductor and basically throughout the whole circuit because it's a series circuit. But what I'm also interested in now for this example is what happens to this node voltage. Let's call it Vx of t. And so actually would probably be helpful also to draw the source voltage Vs of t as well. So maybe I'll do that. I'll just do that right here real small. Let me make another one of these, and I'll just make it small. So we know exactly what's going to happen with Vs of t. It's going to be 3.3 for a really long time, and then at time t equals 0, it's going to pulse down to 0, and then it's going to stay there. And so the question here, so this is Vs of t. The question here is, what does Vx of t look like over time? And so let's just examine what happens here. So first and foremost, I know that my inductor is a short during DC, and so that's the reason why I have 3.3 milliamps flowing during this startup time before the pulse source actually pulses. It's going to just be stuck at 3.3 because this is a short, and so I basically have 0 volts on one side of the resistor and 3.3 on the other. And as a result, that voltage Vx of t, all this time leading up to the transition on the pulse source, that's all going to be 0. So let's go ahead and write that. It's 0 volts all the way up to this point. And so the question then becomes, what happens at the transition when the pulse source goes down to 0? Well, I know that the current through my inductor cannot change instantaneously. We see that. It doesn't just shoot down. It starts to change gradually. So at this very instant, at basically IL of 0, which we know this is our initial condition, it's 3.3 milliamps. So the current at that instant has to remain 3.3 milliamps, okay? Well, what's going to happen then is, if my pulse source shoots down, in order to maintain 3.3, sorry, let me go here. In order to maintain 3.3 milliamps, I know that I need a voltage drop of 3.3 volts across my 1 kilo ohm resistor. Well, I know that that drop is equal to Vs minus Vx, right? I have Vs right here, and I have Vx right here, so that voltage drop across the resistor is Vs minus Vx. And I know that at that instant, when the pulse source transitions, then Vs is going to be equal to 0. So what is Vx going to have to be in order for that numerator to be 3.3 volts? It's going to have to be negative 3.3 volts. Right? And so what that means is that in order to make sure I keep the correct amount of current flowing, my voltage is going to shoot down at the node Vx down to negative 3.3 volts. And then as this current here bleeds off, that's how my voltage is going to come back up to 0, right? Just like this. All right. And so that is the behavior of Vx of t. The important piece is noting why this negative transition occurs, and it is to make sure that when this node goes shooting down to 0, this node has to go down to negative 3.3 in order to maintain current flow through the resistor and therefore through the inductor in order to get this behavior. And so hopefully that makes sense. Obviously, this is a bit confusing, and it gets a little bit dense and tricky with the negative values and all the different nodes and voltages. But this is really the most complex thing that we're going to do in this class has been everything we've done finishing up this module with RL and RC circuits. I'm happy to answer questions. I'm happy to solve more examples. So please feel free to ask. But without any further delay, I'm going to go ahead and wrap this video up, and we are just about done with module 4 instruction. I'm going to do one final video where I kind of overview, compare and contrast capacitors and inductors, and then we are finished with this module. All right, so I'm going to sign off on this one right now.